Yes, today we are discussing rotational dynamics. In this one of the concept, this is a pulley, and the pulley is here suspended by the fixed support and wound with some string, and it is connected to the cylinder. Cylinder is also unwound by using this string with respect to this pulley. This is pulley, and this is about cylinder. This is about cylinder. With respect to pulley, the tension is acting downwards. With respect to cylinder, the tension is acting upwards. Now, we are calculating the acceleration of the cylinder. So that means acceleration of the cylinder is considered A2. So what we are finding here means acceleration of the cylinder. Acceleration of cylinder. So A2 is equal to question mark in this concept. Like this, it is connected and it is unwound. Unwound and it is falling. So that means with respect to the pulley, here center of mass is C. And this is rotating in the clockwise direction. The pulley have only rotational motion. Pulley have only rotational motion because of the pulley is fixed pulley and it have the only rotational motion. Pulley have rotational motion. Pulley have rotational motion. So this is the center of mass C and pulley is revolving in the clockwise direction. So its angular acceleration is considered alpha 1. And at a point of P, its acceleration is in downward direction. What I said here, it have only rotational motion means its acceleration at a point of P is nothing but alpha 1 into R. This is the relation between linear and angular acceleration. Alpha 1 means what here? Angular acceleration. A1 means, AP means linear acceleration. So the pulley is revolving like this and it releases the string. And the cylinder is also rolling the string and moving downwards. So with respect to the cylinder, now we are discussing the cylinder have both the rotational motion and translational motion. I am writing here, listen carefully. Cylinder have both translational motion, translational motion as well as rotational motion. Rotational motion. See here. So that means what is this meaning? At a point of here, at a point of Q, AQ, that is considered. At a point of Q, acceleration is nothing but it have both translational acceleration and rotational acceleration. So here it is moving in the downward direction and it is in the clockwise direction. So therefore, so here A2 is in the downward direction and so that means here what we are writing means alpha 2 into R. This is the meaning. At a point of Q, so it have the both translational motion and rotational motion means it have the two types of accelerations because it is moving downwards and at the same time it is rolling also. The cylinder is rolling and as well as moving downwards. At a point of Q, acceleration, at a point of P, acceleration, both accelerations will be same. So this is also moving in the clockwise direction. So at a point of Q, acceleration is nothing but A2 minus alpha 2 into R. Both the translational acceleration as well as rotational acceleration. This is the meaning. Now, so we are applying the torque on the pulley. So torque is produced the acceleration. So what acceleration? Linear acceleration. Torque is nothing but what here on the pulley we are discussing. Torque is nothing but here. So F into R. So that means F into R. So the torque is also defined as I into alpha. Here this momentum of inertia for this pulley is disk it is considered. Its momentum of inertia is I1. Its angular acceleration is alpha 1. And F means what force is acting? Tension is acting here. With respect to the pulley we are discussing. Now listen carefully. See here. T into R is equal to. So alpha 1 means momentum of inertia of this disk. Pulley is nothing but disk. We are considered. So therefore, M R square by 2 into alpha 1. So therefore, R square and R is gets cancelled. So therefore, 2T by R is equal to R into M is equal to alpha 1. This is considered equation number 1. Similarly, for the cylinder, also torque is acting both so pulley radius and cylinder radius both are identical radius given in the concept. For suppose we are considered. Now the tension is produced the here torque. So therefore the tension T into R is equal to alpha 2 into so I2 into alpha 2. Similarly T into R is equal to so M R square by 2 into alpha 2. So therefore R and R is gets cancelled. That means here the tension will be produced the torque. So the tension is nothing but here torque is nothing but I1 alpha 1 and torque is nothing but T into R. Also we have to write like this. Torque is defined as alpha into momentum of inertia into angular acceleration. And torque is also defined as force into perpendicular distance. This is about the radius. Here from R to this is about the radius. So this is considered. So therefore T into R. After so torque is produced on the cylinder also. So that is therefore. So how to write this one? This 2T by M R is equal to alpha 2. So this is equation number 2. It is considered. This is so, but at a point of P, linear acceleration is in downward direction. At a point of Q, acceleration is also downward direction. Both accelerations will be same. Now, how to write this? At a point of P, acceleration is equal to at a point of Q, acceleration. Both accelerations at a point of P, at a point of Q will be same. So therefore, at a point of P, only so therefore here it is in rotational motion. Only rotational motion means alpha 1 into R. At a point of Q, it have the so both translational motion as well as rotational motion. So simply we are writing A2 into minus alpha 2 into R. Minus alpha 2 into R is take here alpha 1 into R plus alpha 2 into R is equal to A2 acceleration. So what we are finding here finally, what about the acceleration of the cylinder A2? That one we are finding in terms of M1 and M2 and G. So here alpha 1 is already we calculated 2T by R into M into R plus 2T by R into M into R is equal to 8. And R is gets cancelled. R and R is gets cancelled. A2 is equal to 2T is take as M. Here 1 by M1, 1 by M2. So masses will be different we are considered. Here mass is M1. So here mass is M1. Here mass is M2 it is considered. For cylinder mass is considered M2. Given in the question suppose M2 and this mass is M1. Here also M1. Sorry. For cylinder mass is M2. Is it clear? So now A2 is equal to 2T into 1 by M1 plus 1 by M2 for suppose. Now A2 is equal to 2T into what we get here M1 plus M2 divided by M1 into M2. So again how to write the tension? T is equal to finally this 2 is comes into this side here multiplication and division. So here 2 into M1 plus M2 and m1 into m2 is comes into, here it is, this side is the denominator, it comes into numerator. So m1 into m2. So this is tension. We are find it. Finally, we are substituted in the general equation. Constraint relation, equation of motion. What about the equation of motion? The cylinder is rolling downwards as well as rotating also. How to write the cylinder kinematic equation? See here. How to write the kinematic equation? See here. So the cylinder is also rolling downwards. About the cylinder, weight is acting downwards, m2 into g, tension is acting upwards. As a result, it is moving in the downward direction. So what we have, we are calculating A2 acceleration, we are calculating in terms of m1 and m2 and in terms of g, not in terms of t. So finally, here t we are substituted. So therefore, m2 into g, so therefore minus m2 into A2. So simply we are substituted T tension. About this cylinder, we are writing this. So T value we are substituted M2 into G minus, what about the T? A2 into M1 into M2 divided by 2 into M1 plus M2. So this is equation number 3, it is considered. This is substituted in equation number 4. How to write this one? Weight is acting downwards and tension is acting upwards. As a result, M2 A2. So A2 means acceleration of the cylinder. So finally that is equal to M2 into A2. Here M2, here M2, here M2 is take common, that is cancelled on both sides. So therefore 2 into M1 plus M2 into G minus A2 into, here M1 is remaining, divided by 2 M1 plus M2. So that is equal to A2. But we want only A2. So that's why, see here, we want only A2. So 2 into M1 plus 2 into M2. This is into G is also there, plus G. Here also plus G. This is M1 A2 divided by 2m1 plus m. So that is equal to 8. So this is, take this side, 2 into m1 plus 2 into m2 into g minus m1a2 is equal to, completely comes into this side, 2m1 into a2 plus 2m2 into a2. See here, m1a2. Here m1a2, this one is comes into this side, and this one is comes into this side. Now what is becomes here, 2m1 2m2 into g minus, this is, here this one is comes into this side, becomes m1 into a2. Here 2m1 into a2, it becomes 3m1 into a2 plus 2m2 into a2. So finally a2 is take common. So this is 2 into m1 plus m2 into g divided by, so here a2 is take common means 3m1 2m2 is equal to a2. This is the acceleration of the cylinder. Now this is the concept. Simply I can explain once again. This is a disc or pulley, frictionless pulley. Here this is a cylinder. This disc is releases the string, and this is unwound. Cylinder is unwound, and it is moving downwards. It is revolving, and at the same time it is moving downwards. So that's why it have only translational motion fully, and but cylinder have the both translational motion and rotational motion. After simplifying this one, all this procedure we are following, we get, this is the answer. A2. A2 means acceleration of the cylinder. 2 into m1 plus m2 by 3m1 plus 2m2 into g. Yes, thank you all of you. I hope everyone understood. Thank you.